Okay, I'm still figuring this video thing out, so forgive me if you get sick watching this because my phone keeps bouncing all over the place. And if it just suddenly terminates, it's because someone called me. And anyway, still figuring this stuff out. Bear with me. Okay, so I printed out a practice test and I grouped problems together to help you. So the first group of problems we're going to look at is word problems that they want you to come up with an equation and solve. All right. Now then, in word problems, there are things that you look for. Okay? So for example, and if the word problem says something like more than, greater than, or vice versa, less than, or something like that. Let's put that in there, less than. Okay, usually they're going to have, so-and-so has 500 blah, blah, blah more than George, yada, yada, yada. They're comparing two numbers. So usually if you see these words, our first inclination is to do the inequalities, the little greater than or equal than symbol. But in word problems, these guys usually means we're going to add something. This means we're usually going to subtract something. Okay? If they're using words like at least or at most, what else? If they use like, what is the minimum? I know I spelled that wrong, don't tell your mom. Or what is the maximum? These words in a word problem, you are instead of using an equal sign, we're going to use an inequality, right? So if, for example, if I say I have at least $20 in my wallet, that means I have $20, but I could have $21, okay? So at least, it's kind of backwards thinking. At least means greater than or equal to, okay? So if I have at least $20, I could have exactly $20, or I could have $21, all right? If I said I have at most $20 in my wallet, that means I think I might have 20, but I can't remember if I bought a candy bar. So at most I would have $20, but probably I have less. So at most means I have exactly $20 or I have $19 or less or something like that. Okay, so they're kind of backwards thinking. All right. When it asks what's the minimum she can spend or whatever, then usually this, again, the minimum she could spend would be I'm trying to think, maximum. The minimum would be greater because, the minimum could be this number, but she could go greater. The maximum, she can't go past this number, so the maximum has to be less than. And, of course, it has to do with the context of the problem. I may have these backwards. It just depends on how it's worded. Okay, so if you see these words, then we're going to have some kind of equation that has a greater than symbol or whatever. Okay? If you see these words in a word problem, usually it means, Greg is 5 inches greater than George or whatever. So, Greg, we're going to add 5 inches to George, whatever George is, etc. and so forth. All right. Other keywords to look for is the word per is used a lot. And a lot of times, it depends on the context. This could mean multiply or divide. It could mean multiply or divide. Most of the time in word problems, it means to multiply, okay? Usually, I don't know. When we'll look at these problems, and if I run across more words, we'll add it here. The other thing is the word is. All right, is always means equals. All right, the cost is blah, blah, blah. Is means equals. All right, so those words. So let's look at this word. Where to go? Right here, in this problem right here. Sorry again if I'm making you sick. All right. So what this says is the length of the largest fish is 967.74 times greater than the length of the smallest fish. Okay, select a variable expression that shows the length of the largest fish if S is the length of the smallest fish. Alright, so by the way, back up here, this word variable means a letter that represents something, okay? So in this case, the letter S is a variable that means the length of the smallest fish, okay? So let's look at this. The length of the largest fish is, alright? So we're just going to, if this was a word problem that you had to write, let's just use L. That means largest fish. Okay? So, that first phrase, the length of the largest fish is, right there tells you if we were to write an equation, it would be L equals. Now, then they say expression. So when they say expression, they usually mean everything after the equal sign, and we're just going to get rid of this crap. Okay? So we'll come back to that. So right now I'm going to write the equation because it applies to all the others. All right? So the length of the largest fish is 967.74 times greater than. All right? See that word times? That's a dead giveaway. All right? Greater than. So that means it's going to be bigger. All right? So when we divide, we break things into small pieces. When we subtract, we, go smaller. When we see greater, it means we're making something bigger, right? That word right there means that's exactly what it means. 967.74 times. All right? 960, sorry, trying to see all of this, 67.74 times. Now then, when we start with all these letters, I don't want to use X for times. I'm just going to use a dot right now, okay? Times greater than the length of the smallest fish. All right, select a variable expression that shows the length of the largest fish if S is the length of the smallest fish. So they already give you the variable. So we don't know what the length of that small fish is, but we're going to take that small fish and multiply it by 967.74. That small fish was either really small or that big fish is really big. Okay? And now my S's tend to look like 5s. I'll try to make it look more like an S. So that would be the equation. Okay? But since they asked for an expression means we're just going to knock this part off. So we're going to look for something that has this number and S multiplied together. Okay? So in your multiple choice, S plus, well, if it just said 964 greater than, we might say plus, but this word times is a dead giveaway. So it's not plus, it's not minus. Those two are next to each other. That means multiplication. This is a fraction. Fraction means division. So that's what it looks like. And it looks very similar. You don't have to have the dot. You can put the letter right up next to it. Same difference, okay? So that's that's going to give you an idea of how to read the words. All right? All right, this next one kind of goes to the next step. All right? So, Daver, whatever, needed to rent a van to move. Okay? That sentence has nothing that we care about in math, so we're just going to move on. The next sentence. The van cost $104 to rent. Whoa, stop right there at the comma. So you go to U-Haul, you say, dude, I want to rent a van. They're like, okay. First things first. I need $104. Okay? I don't care if you just go out there and sit in it for 4 hours and then change your mind. It's going to cost you $104 for me to hand you these keys. Okay? So there's no no words next to that to say we're going to do math with this, other than anything else, except for this word that comes right after the comma. It kind of just, hello, we're going to take this and we're going to add it to something. All right, so since there's no words like per or any of that stuff that we talked about, it's just this lonely number, and we're going to add it to something because of that word plus. All right, so what are we adding it to? The next part says 24 cents per mile driven. Okay? This right here is when per means multiply. All right? If I go 1 mile, it's going to cost me 24 cents. If I'm going to go 2 miles, it's going to cost me, 48 cents, etc. and so forth. Okay? Remember, if we're talking about money and someone's trying to get money, or you have to pay money, the money's going to get bigger the more you use it. Okay, so if you end up dividing, that's going to make this smaller and smaller and smaller, and that doesn't make any sense because if I'm the U-Haul guy, I'm in the business to make money. Okay, so this right here means multiply. And then how many miles, the next sentence is a question, how many miles did David travel if he spent a total of $142.40? All right, this word total we need to add over here. All right, when they have total, that usually means equals as well, because we're totaling. And yet totaling up means that we're probably adding some stuff together in there, okay? All right, so let's look at this. So we've got 104 plus 24 per mile. And it totals total of. Okay? So, let's write this. So 104 plus 24 per mile. Okay? Now then, you need to pick a letter, and tell me that it represents the number of miles, because that's what we're trying to find. Okay? You can use the letter M for miles, or X, because X is really common. Whatever. If you look at your answer selections, they use X. Okay? So we're just going to do X. So 24 cents times the number of miles, X is the number of miles, is going to total or equal $142.40. So there's my equation. Okay? So that's what you would pick. All right? If you didn't have multiple choice, that's what you would write here. If it's multiple choice, you're going to look for something that looks very similar to that. I mean, the order doesn't matter. You could flip things. They have it flipped around, but that's okay. It's the same stuff, right? This is the same thing that I did. All right? Not dividing, because if I divided, like if I took 10 divided by that plus a 104, I'm not going to get this. And that's a good thing to do if you're not quite sure, is just come up with numbers, plug some numbers in there and see if it makes sense. You should be getting numbers big, you should be getting numbers that are making this a whole lot bigger. Okay? So this is your equation right here. Okay? So then the next thing is well, how many miles is it? Okay? How many miles did he finally go? So that's where we got to solve this problem. So let me come back up here. So the steps to get X by itself, or any variable by itself, is we do kind of the opposite or the reverse order of operations. Okay? Order of operations says we add and subtract, then we multiply and divide. I'm sorry. I got that backwards. Order of operations says that we multiply and divide and then add and subtract. Okay? When we're trying to get X, we want to undo it. We need to get rid of anything added or subtracted to the thing, the glob, that has the X. So see how this 104 is added to that? We need to get rid of that and move that over here. Okay? So we're going to do opposite of what this says. This says 104 plus that. We're going to subtract 104 from 104 so it goes away. Okay? We need 104 to go away on that side. So 104 minus 104 would be 0. Well, we can just cross that out because it's gone. And then we got to walk across the street and subtract 104 from here because it's like a teeter-totter or a scale. And you got to keep things equal. So whatever I do over here, I have to do over here so that everything stays the same. Everything stays equal. So this is gone, and I'm going to take 104 away from this guy. All right. So what's left, since this guy's gone, is 0.24x on this side is going to be whatever that is. 142.40. Take away 104. $38.40. Okay, so I take away 104 from 142.40, I get $38.40. Okay, now then, to find what x is, we have to do opposite. 0.24 is being multiplied to x. To undo the multiplication, to get rid of that number, we have to divide. If we divide 0.24 by 0.24, it becomes 1. So we're just left with 1x. All right, so that's gone. But again, whatever we do to one side, we have to do the exact same thing on the other side. So we have to divide this side by 0.024. Okay, so then everything that's left here is x, and then we do this math right here, and we get 160. Okay, so x is 160. What did x represent? The number of miles that Dave or David, whatever, drove on his rental truck. Okay, so 160 miles. And if you're not sure, you can always plug it back in to to the original formula. Okay, so 0.24 times 160 is 38.4 plus 104, and we get 142.40. Okay, so this is my answer. Hopefully this is making sense. Okay, so one more, because this one is an inequality. But it's the same thing, same idea. Okay? So we got Danica here, and she sold a painting for $435. Period. Boom. Done. Okay? So if that was it, that was the end of the problem, then all we know is that Danica has $435 in her pocket. Okay? All right, so that means, since that number is all by itself with a cents, that means we're probably going to add it to something else or subtract it to something else. So just be ready. We're going to do something with that 435. All right? She then auctioned her doll collection, earning $20 for each doll. Now, this word collection means more than one. All right? If you got a rock collection, you have more than one rock. You probably have several rocks. Or a baseball card collection, which nobody does anymore. But anyway, whatever. Seashell collection, whatever. Okay, so there's more than one. And so she sold the whole thing, but each doll got $20. So if she only had 2 dolls, she got $40 out of the deal, right? If she had 10 dolls, 10 times 20, she got $2,000. So how much money she has depends on how many dolls she has, okay? So right here, $20 for each doll. That right there means I'm going to multiply 20 times something, okay? If she made at least $955 for the painting and the dolls, what is the minimum number of dolls she sold? Okay, so see that word, at least? At least means that she made, according to our little conversation earlier, she got $955 or more. Okay? Or more. So at least means we're gonna use that guy right there. Okay? So first we got to come up with an equation. Well, before we come up with the equation, we really need to define a variable. The one thing we don't know is how many dolls she has. Okay, so let's say D is number of dolls. Okay? Now then, once we have that, let's go back. So, if D's the number of dolls, how much money did she get for each doll? Well, she got $20 for each doll. So $20 times each doll, right? But that's not the only thing she sold, right? She sold a painting. So 20 times the number of dolls plus what she got for the painting is going to be at least, this has got to be at least $955, right? $955. She may have gotten more, but she got at least that much money, okay? So she probably had a bunch of dolls in there. So there's your equation. All right? Now then, to figure this out, you're going to do the same thing. Even though we don't have an equal sign, we have a greater than or equal to sign. Same thing. We always have to undo anything added or subtracted to the thing with a letter. So 435 is added to the 20D. So we need to get rid of that 435. So we subtract it. We do opposite. Whatever we do on this side, we have to do on this side to keep things equal. This goes away because it just becomes 0, and 0 doesn't matter in this point. And then we're going to do 955 minus 435, which is 520. So what's left is 20D greater than or equal to, what did I say, 520. Okay? Same thing. Since 20 and D are being multiplied together, to undo the multiplication to get D by itself, we got to divide by 20. Divide by 20. So then D is 520 divided by 20, which is 26. Okay? So, the number of dolls is at least 26. The minimum number. The minimum number is 26. She may have more, but the minimum number of dolls, whoops, is 26. Okay? All right. I'm going to stop this here and get this one uploading, and then I'm going to do part 2, which will be another group of problems.